a graph of the function f of x equals x cubed minus x. Okay, so that's this graph right here is given. The numbers inside the shaded region give the area. So let's shade these regions here. So this region, this first one has an area of 1/4. The next one has an area of negative 1/4. And then this last one from 1 to 2 has an area of 9/4. So what I want to do is I want to calculate the integral, the definite integral from negative 1 to 2 of f of x dx. Now f of x dx is x cubed minus x. Okay, so I'm doing this graphically. So that means I got to make everything based off of this. Now since this is already f of x here, I don't need to do any manipulations with that function. I just need to sum from negative 1 to 2. So from negative 1 to 2, negative 1 starts here and it goes to 2 here. So that's all the areas. So the first area is 1/4. The next area I'm adding is negative 1/4. The next area I add is the 9/4. So what happens, these first two areas here, this is a negative area and then this is a positive area. So those two cancel each other out at 1/4 and negative 1/4. So my answer that's left is just 9/4. Pretty easy, right? We're looking at the picture and figuring out what the definite integral is evaluated at. The next one is a little bit different. Why is it a little different? Because our function now is 4x cubed minus 4x. So I have to ask myself, how does that relate to f of x? Okay, how does it relate to f of x? So from the picture, I see from negative 1 to 0, negative 1 to 0. So we're probably dealing with this area here, and that 1/4 is going to play a role. But what I don't see is, this isn't exactly the same function. Now what I notice, the only difference is it looks like these have 4s in them and these have 1s for the coefficients. So what I'm going to do is I'm going to factor a 4 out of each of those two terms, and what I'm left with is x cubed minus x times 4. Guess what? X cubed minus x times 4, x cubed minus x is my f of x. Bingo, that's what I want. So what I'm going to do is I'm going to use a constant multiple rule and pull the 4 out of the integrand. So I have 4 times the integral from x cubed minus x from negative 1 to 0 dx. This is f of x. So now I know this area is represented by this 1/4 here. So I'm going to replace that integral with this area, this definite integral with that area right there of positive 1/4. Multiply it out, I get 1. Okay? This next one here, right? Another algebra trick we're going to need to make it look like my f of x function. Right now, it looks like I have something cubed and then minus something, right? So that's something cubed minus something. So instead of f of x, I have f of x minus 1, right? And so this is x minus 1 cubed minus x minus 1, okay? So that's like my f of x, which is x cubed minus x. That's my function. So what's happening here? It looks like that minus 1 input in the parentheses, you think back to your college algebra days, if I had like x minus 1 squared, that would be the parabola x squared shifted what? Shifted to the right 1 unit, right? So that's, that brings you back to college algebra days. So what I'm going to do is I'm going to have this graph shifted to the right 1, okay? So let me see. I can't remember if I did. Yeah, I was afraid of that. All right, well, maybe it might be easier instead of moving the graph if I just move the axes. Okay, so shifting the graph to the right shifts this whole thing to the right, okay? And so what's happening here is the bounds are changing, okay? So now what I'm going to do is I'm going to make what's known as a u substitution. So I'm going to call u equal to x minus 1. That way I can write this integral in terms of u. And so I have u cubed minus u, which is just like x squared minus x, okay? And so because I changed this to be in terms of u's, I need to integrate with respect to u. But if I'm changing everything to be in terms of u, I've got a problem. Because here my bounds were saying start at x equal to 2 and end at x equal to 3. You see? Start at x equal 2 to end at x equal to 3. Well, guess what? If I start at x equal 2 and I end at x equal to 3, there's no area right there. My picture doesn't work for that. I don't have it, okay? However, what do I know? If u is equal to x minus 1, right? How do I get this lower number here? I use the x equal to 2. So I plug a 2 minus 1 in and I get 1. So I put a 1 here. And then up here is same thing. If u equals x minus 1, to get this upper bound, I use the x equal to 3. So I have 3 minus 1, which gets me 2. So my 2 goes up here. So if I have it in terms of u instead of in terms of x's, the x equal numbers on the limits of integration no longer work. I need to make it in terms of u equals numbers, okay? So this is a tricky one, no doubt about it, all right? So the limits of integration change from x equal 2 to x equal 3 to become x equal or u equal 1 to u equal 2. And so now I try to find, okay, definite integral from 1 to 2. So from 1 to 2, that's this triangle right here, which has an area of 9 over 4. This last one here, this one's another tricky one. Okay, so what's going on here? This is f of x right here, okay? But then I also have a 4 right there added to it. Okay, I have a 4 added to it. So what I'm going to do is I'm going to split it up. I'm going to divide it up into two integrals. One where I have my f of x, okay? So the first integral, my f of x, is this part right here, okay? That's my f of x. The second integral is my 4 right there, okay? Now you think about the line of 4. When I graph 4 here, it's y equal to 4 is a horizontal line at y equal to 4, and I'm summing from -1 to 0, okay? So I'm trying to find the area of this rectangle. Well, the rectangle has a height of 4 and a base of 0 minus 1. Well, 0 minus a minus 1 gets me a plus 1, right? So 1 times 4 gets me 4 for that geometric area. All right? So this first part here, -1 to 0, has an area of 1/4. And then the second part here, we found that that area of 4 is a rectangle with base and height of 1 times 4, which gets you 1/4 plus 4. And so when I simplify this, add it together, I get 17 divided by 4 for my final answer there. Okay?